So I've been a cloud solution architect at Microsoft for almost 3 years now. Prior to that, I've spent 5+ years for either consulting or direct hands-on at different organizations for Azure data engineering, SQL DBA work. My expertise at Microsoft is in data analytics. So we're talking about Microsoft Fabric, Azure Data Factory, Databricks, Azure SQL, everything to do with data analytics, but I'm also an expert in AI as well. So I am in healthcare exclusively at Microsoft. HLS is healthcare and life sciences. Prior to all that, and meeting Greg and working with some of the folks on the call here, I was an X-ray tech out in Philadelphia, primarily working in the operating room and emergency departments. So I always have nice stories if folks ever curious. And that also makes me a huge Philadelphia sports fan. It was really great for football season, but the Sixers and the Flyers are just really, really sad now. So it's not a great time. Now, outside of that, I'm located in Charleston, South Carolina. So lots of time, like to be out at the beach, like to be trying new food. There's lots of food here. And you can see my 2 dogs on the screen at the beach. But feel free to connect with me on LinkedIn. Ask me any questions that way. However you want. If for a follow-up, you can certainly reach out. So the agenda, it's going to be pretty light in terms of slides because I find it best to go over the concepts first about what we're going to be talking about, and then getting into how it's built out in actual data factory. So we're going to talk about metadata-driven processes, really what it is, what the framework is, and then also review the architecture and components, and then that's what that live demo is. Now, if I had to put a goal for today, so folks may or may not know what metadata-driven architecture is. It might sound like a mouthful. The goal that I would love for you to take away from this session is not to be 100% confident to say, I know how to build all this stuff out from scratch. Marc was the best teacher in the world, right? Obviously, that'd be great. And maybe that's true. But really, I want you to just at least start thinking about anytime you have to architect something or build something, to at least ask the questions, be like, how can I scale this? And just either metadata or something like that, just really asking the questions. So as long as in the future you kind of say, what was that guy from Microsoft talking about? That's a win, right? Because this is recorded, you can always go back. And I also have a blog out there that even walks through this. So if you do forget, there's that too. So that's the goal for today, for just to kind of change your thinking a little bit. So really, what does metadata-driven ELT or ETL mean exactly? So ETL, extract, transform, load. ELT is just the newer version of extract, load, transform. The reason is just for the cloud. I won't get into kind of the benefits, but if folks have questions, we can certainly talk about it. But what metadata really means, right, is just data about data. That's all it is. So when we talk about metadata-driven architectures, all we're doing is the whole goal is just to pass a framework, like a scaffolding, and pass through parameters to loop through metadata, which can then help drive our actual data and our ETL. So the whole point is to build out a template or a scaffolding, whatever you want. And metadata can be whatever you want to call it, right? I call it metadata-driven ETL. Sometimes folks call it configuration-driven. You really can use any name you like, but the important part is that it's data about data. Now, why would it be useful? Well, the best scenario that I always have, and I'm in healthcare, so I'm used to working with, let's say Epic data, right? There's lots of data out in Epic or just any really EHR system, right? So what if you have to move, we'll just keep it simple, right? Load 500 tables, just moving data from point A to point B. Well, how would you do that? Well, you built some sort of process. So whether it's in Azure Data Factory, whether it's in Fabric, whether it's in, Informatica, whether it's in Talon, whether it's in Control M, whether it's in Spark, how would you do that? Well, you could certainly build 500 different objects, right? In ADF, we'll build pipelines. So you can certainly build 500 different pipelines. Well, that is, taking out the fact that every single service or technology stack that you use will have some limits, whether or not 500 objects is going to be the limit or not. Taking that out, it's just going to be a nightmare to manage, right? Any changes you have to do as you scale, building 500 objects, that's a lot of time just to build that out. Well, if the pattern's the same, right? It's from the same source, it's going to the same place, and it's a pattern. Why can't we just build one pipeline and then pass through 500 objects in there? That's the concept of why it would be useful. So common scenarios, right? ETL or ELT, building an enterprise scale with as little objects as possible. That's the whole goal of this.
Can I ask a quick question on that, Marc?
Yeah.
So, I hate to bring AI into the picture, but with AI, metadata is so important, right? And so is that yet another reason where not only can this help, programmatically, manage your pipelines and simplify that, but also, like when you think of like how's AI going to work with this data, it's like double fold win-win.
Yeah, because when we think about AI, I have this conversation with customers all the time. It's really powerful, but bad data in, bad data out. So and all these AIs, they work, whether it's Copilot, whether it's anything out there, it's working off your metadata. So for example, if we load data into, let's say, a SQL server or a SQL DB, or if you load it into Fabric and you expose the schema to the AI, well, it's only as good as what your metadata is. And schemas, column names, data types, that's all metadata. So it's only as good as that. And I always describe it of, if you have a table and you have a column name actually listed as column 1, well, the AI, just as much as a human, is going to struggle to identify that, to figure out what the purpose of that is, right? Just like and I always think about of any new employee coming in. If it doesn't make sense to them, it most likely won't make sense to an AI. Sure, it can determine off of like, hey, this is an integer and it's got like, 9 digits. Maybe this is a phone number, right? It can do some inferences that way, same thing as a human can. But to your point, Greg, yes, 100%. Like your metadata is very, very important. And so you would be able to leverage this if you've built it out in any way, shape, or form.
It's pretty awesome.
I mean, Azure SQL DB can be a vector database anyway. So if you had this information there, which is what I'm using for this, you could use it as a vector store. Now, we're not talking a bunch of data that would need to be all crazy indexed like a vector search would be, but it would still contain as a pointer or a source for your data stores.
Cool. Thanks for addressing that.
Yeah. And this concept, I really want to drive home. This is not specific to a specific technology. So I listed off a bunch, right? Name your tool. You can even go back to SSIS. You can anything that you're doing ETL or ELT in, or something that's repeatable, whether it's executing PowerShell scripts, whether it's executing CI/CD, whether it's executing really anything that you can possibly think of that is a process that needs a script to run. This concept can apply. So that's what I mean by the goal, right? I just want you to start questioning things in your work, in new or not, don't go around questioning everything. I don't want to get you in trouble. But anything brand new or anything you're looking to optimize, and anything that's maybe some pain points of like, oh man, every time it's really annoying when a change comes in, we have to just, do X, Y, Z. The goal again is ask the question is, can this be metadata driven? Can we improve this? Can we, do some sort of patterns, some scaffolding, whatever nomenclature you want to use? Can you do something? That's what I want you to take away from all this. Now, in our scenario that I'm going to show you, we're just going to be loading data from Azure SQL to ADLS to simulate a staging environment, and then to Azure SQL again. And we're going to get into the different sources, but essentially there's 3 components, and this is going to be across the board. So you need to have a metadata table, and I have it in SQL DB. You could call this a config table. You could call this really anything that you'd like. It could be a file somewhere that you're pulling in. It's just a matter of this actually contains the configurations that is going to actually reference what's needed to perform the ETL for each table end to end. So extract from the source what the transformation is and actually load it, or load it and then transform it. So we're going to see the end-to-end process here all orchestrated from a single table with all the configurations. And if you're confused about what this really would do, the metadata table is really designed to drive the where, the what, and the how about your entire ETL process. Where is it going? What's it doing? And how's it getting there, right? Now, in our example, we're going to use ADF pipelines. So these pipelines are going to be scaffolding. They're template pipelines. And what's going to happen is that we're actually going to only have 3 pipelines, which can scale up to n number of tables. We're only going to use a small batch of like 10 tables just because for simplicity of the demo and the concept. But this really can be used for n number of tables. I personally have implemented this at customers back when I was a consultant and also working as an engineer for 500 plus tables. It's extremely scalable. And working for Microsoft, I will tell you that every single customer that I work with at large scale utilizes this concept. Now, everyone has, sure, different variations, but every single customer at large scale has to use this sort of concept. And again, in any tool that they have. So what's going to be a little bit different is that at the end, I have some custom SQL logic. So if you're wondering to say, okay, Mark, well, we have full load tables and we also have incremental tables, right? Some tables get really, really big and we can't load 100 million rows a day, right? We can't move 50 gigabytes every single day in process, right? That takes hours. Our SLAs aren't there, just processing and cost. It's a lot. So you might need to incrementally process. Well, is there a way to do that in a pattern to actually merge or insert and update those records? And the answer is yes, absolutely. So we're going to see some of these pieces, and that's just one of the extra pieces that's extremely custom that I have. And it's just a SQL script. There's some fancy dynamic SQL, but leveraging the same exact infrastructure that we're using. So we have one script for all the incremental tables. Now, what's important as well when we get in here, and I'll be sure to note it. So it's a pipeline, and I mentioned a lot of other customers. This is not just for SQL. You can parameterize and call anything, APIs, other technologies outside of SQL. So MySQL, Oracle, name your SaaS. This could be pointing to S3. This could be calling logic apps, could be calling Databricks notebooks, could be calling anything. Anything can be parameterized. All these connections can be parameterized. So that's why I say, and if you're running a theme here, hammering the goal is, I want you to start asking the questions in your process to start thinking in a way to leverage these ideas. And so the most common example is using Databricks, right? So I have all these Databricks notebooks or even Spark notebooks, whatever tool that you want to use. Well, what if you have to, and the classic is, well, we can run Spark jobs. Great, that's awesome, really easy. And you can parameterize those, no problem. But the question about where does ADF or some other or scheduler or orchestration tool come in is when you have to do things outside of Databricks or outside of Spark, right? They have to build dependencies. You might not be able to do everything in Spark. For example, you might not be able to send email tasks. You might not be able to perform some other stored procedure tasks elsewhere, right? Anything that's before or after. So what do? Can you use a single tool to parameterize and still be able to leverage your entire end-to-end process? The answer is yes, through parameterization. And every single customer that I have that's extremely large scale, and every single, I'm sure the folks on the call are also aware too, like any single product that's out there, any service that's out there is leveraging this concept. Whether they call it the same or not, it's parameter driven. ETLs or ELTs are doing any sort of streaming, things like that. They're all leveraging some sort of parameterization and dynamic loading process. Just because at large scale, we're talking thousands of tables or thousands of objects that need to be orchestrated, and no one's building 500 to 1,000 objects that are just repeated, right? So that's the concept. Question from Brian, is the config object always or almost always a table? Any weird edge cases where it is not? I prefer a table. I mostly see table just because of the ability to filter it. You can absolutely make this a full file. So you can make like a config file and have it like even as like a CSV, for example. It's just that if you want to start filtering it, so to say, hey, I contain, let's say, and we'll talk about this further when I kind of show you the metadata table next. But if you wanted to have like a bunch of different workloads inside of the same table, well, you're going to need to filter that. That way, when you call in the objects that you want to loop through, you want to be able to filter out the stuff that you shouldn't be executing. With a file, you're going to have to bring that in and then perform filtering. So you're going to have to read the whole file. So depending on your process, like it's all doable. I just mostly see tables just because of the ease that way. But I also have seen files as well, especially for like PowerShell, things like that. Like depending on what you're orchestrating, whatever your comfort is going to work to pass through config files. Hope that answers the question. So an example of this metadata table, this is just a screenshot from SSMS. So now there's lots of columns here. We're going to walk through each one. But on the left-hand side, we have file name. So I have the file name, so customer.parquet. Making this the file that I'm choosing is a customer parquet file. Now I'm also passing through the storage count. Same thing with the storage container. And then the directory path within that container. So you can see with the file name, storage account, storage container, directory path, I'm having everything to point to a file location in this table. Now I'm showing you all of this stuff first. I'm going to set the stage entirely to show you everything that's parameterized before we actually start walking through the pipelines. So you can see hey, we know that this process is taking from SQL and moving to ADLS for staging and then loading into another SQL environment. So we're taking that and putting it to this storage location. And each file is going to be a unique file with its own name. Now, just to kind of skip around a bit, source schema, source table, staging schema, staging table, target schema, target table. This is from the source, just like what we talked about before of, hey, the source may be different. The source or the destination also may be different too in terms of naming. Maybe your source just has DBO. I highly hope it doesn't, but I've seen some weirder things. The schemas can be all different. You might want to use a stage schema for your staging tables. You can do any of those pieces, right? So I have those included just to signify what I'm pulling in. Now, something that I also have here is a load type. So signifying either it's a full table or incremental. So I only have 2 incrementals, like think about your big fact tables. I have a load indicator. So this is, and they all say daily, but this is kind of the kind of alluding to the answer that I gave to Brian's question about if you wanted to include things, let's say on different schedules, like for example, monthly or daily. If you had this in a table, you'd be able to send a query to say, hey, give me all the dailies or give me all the monthlies, and it's stemming from the same table. You could certainly do that with a file, but you're just going to have to filter it later on, which can be resource intensive because it's a file versus just trying to read through just what you need. But that's what that load indicator is. You could also have ad hoc. You could also have testing. Like you can have anything that you want in this metadata table. The important part is just making sure you understand what the grain is, so what the unique record would be in here for your processes. And that will make more sense as we kind of go through what it's doing. The other pieces in here that I have are column key. So this is your primary key. Now, I know that there's probably some database folks on here and maybe listening to the recording that say, Mark, primary is a singular word. It can't be more than one key. So why is there a comma separated list? I also find that primary keys also do not mean one singular column, and that's okay. We would call those composite keys. But some tables may require more columns to identify a unique record than a single key. So that's what that's there for. And why is that important? Well, when we're doing incremental processing, we have to do a comparison. We have to take the unique records and do a comparison of the data. Or at the very bare minimum, identify which records have changed and we can delete them and then insert the new data. So we have to be able to identify in a dynamic way how to identify the unique record. Now, that brings us to our next column, which is a waterfall column. There are many ways to identify change across your data. Specifically for SQL, there's CDC, there's change tracking, there's waterfall columns, which is just a reliable date column. Anytime that something has changed, something in your process updates the timestamp to say, hey, this has been up, this row was up last updated, April 22nd, right? The other ways that you can do it, identify change, you can certainly build a hash column, which is basically just a hash key across all the rows or all the columns in that row. It's really resource intensive and expensive. And you would just compare the hash values to see what's changed. But it's a way. I always describe that I'll tell you probably all the ways, whether good or bad. That's probably the worst way to do it just because of how many resources it requires to actually create the hash and also do the comparison. So the question I get asked a lot is, well, Mark, does this work for CDC? Well, the answer is yes. And I'll show you why later, because this is going to, again, work for any type of source that you have, any sort of target that you have, any sort of, whether it's API, any sort of technology, this concept will work. You just have to adjust it for the right syntax and what you're doing. So for the waterfall column, I just have modified data in here because that's just what I have as a reliable field. Now, table columns, again, the DBAs and the folks on the call, please don't yell at me for the select star. I did it for simplicity. Folks on the recording and also here, please never do select star. We do want to actually hard code the column names for various reasons. One being schema drift. Another being you might not need all of your columns. If there's 300 columns in a table, do you really need all 300? Because that all has to move. There's physics involved when we're moving data. So the less, the better. The less is faster. So we always want to do that. But for this demo, we're just doing select star because it's easy. Now I will say this does not have to be perfect. Like this doesn't have to be your columns. You don't have to do exactly what I did because it's a metadata table. It's just describing data about data. For my process, this is all I need. You may include more columns. You may include different columns, and that's okay. You should make it as robust as you need it. You can over-engineer it like crazy if you wanted to. And something else that I see sometimes is your metadata table can also be used for logging too, right? So you could have had columns in here for the last executed time. As part of your ETL, you could just still part of your pipelines pass through and just update this metadata table for error logging, for obviously the grain of the table matters here. Like you wouldn't keep a full daily run. You can just have the last status, but it's something that you can do. So really this metadata table or config table, whatever you want to call it, or config file, it can be as robust as you need it to be or as you want it to be. I've seen some pretty crazy stuff. I've also seen, just two columns in here. And that's okay. There's no right or wrong answer. It's just whatever's going to work for your process. The only thing that I will say that you shouldn't include in here are like connection strings or username passwords. Please don't include them in here. Technically, yes, you can do that. And yes, you would be able to pass it through to your stuff, but that's just really bad security practice. We have other methods in Azure specifically. You can store that stuff in the key vault and pass that through dynamically as well. So you could just pass through a connection string here for the key vault if you wanted to. Not a connection string, but at least the key vault name. But yes, that's my only disclaimer, is that please don't include anything that's sensitive in here, like connection strings or or actual credentials. Are there any questions so far?
We all want the live demo. Live demo, live demo.
I ran this earlier, so it should be okay. Okay. So in Azure Data Factory, like I said, let me back up a little bit. So I'll show you the Azure portal. So I have an Azure SQL Server database, and really I have just 4 databases in here. And so for simplicity, yes, this is the same server, but I'm moving data from the source system database to the prod database. That's all I'm doing conceptually. So it's called SQLDB MB prod, SQLDB MB source system. Now, before I get to the actual pipeline and showing you things, what's important for Data Factory and what's critical for this process and just any sort of process at scale is the link service. So the link service is your connection, right? It's what's actually doing the connection. There are 2 bits to making a connection within Data Factory. So can you just randomly reach out to a source? The answer is no, you can't. You have to create a link service, and in that link service, you have to use an integration runtime. Integration runtime is the middleman. It's conceptually similar and technology very similar to gateways in Power BI, or any sort of middleman VM. It creates the pipe in between the source and the destination, and it also provides the compute power to actually move the data. What's extremely important about Data Factory is that Azure Data Factory does not store any data ever. It doesn't store anything. No data physically lives here. It lives in the source, it lives in the destination, and it lives in transit, just like how you normally would move data. So you have to create the pipe, which is the integration runtime. I'm using Azure integration runtimes. There's different types. There's the Azure integration runtime, which runs on over public IPs. There's the self-hosted integration runtime, which is also called Shire, if you've heard that. That is where you spin up your own virtual machine and install the software for the integration runtime to do that connection. So you own that VM. That's able to connect across private networks and on-prem, all those wonderful pieces. There's also the Azure managed VNet integration runtime. A little bit more restrictive than the self-hosted integration runtime, simply because Microsoft owns it. So it only really has insight into things that Microsoft has visibility into. Then there's also what I do not recommend. So you're getting some free advice on this call if anyone's migrating from SSIS. You can do the integration. There's an SSIS integration runtime, which would allow you to execute SSIS packages in the cloud. The reason why I laugh and I say I don't recommend that is because it's the most expensive option to run SSIS. The reason for that is in Azure, the SSIS integration runtime is one of the more expensive integration runtimes to have. And in order to actually run SSIS, you need to host it on an SSIS DB, and that has to be in the cloud. So you have to choose either Azure SQL managed instance or an Azure SQL database. So you have to spin up one of those, which adds to the cost. So it's just a really expensive way to run SSIS. I suggest just migrating and running something, or at least just orchestrating it on-prem as is. But I highly suggest migrating to something in the cloud. Anyway, that's just some free advice there about the IRs. So ignore this big red X, but I'm just using the auto resolve integration runtime. And back to link services. So this is your connection, right? So you choose your connection. It's, you can search by type. There's lots of these. So if I go to, oh, that's great. I forgot that my Git was off because I was doing some experimentation. So I won't show you any of these, but I can show you the existing ones. So what we're connecting to is Azure SQL Database. So I have one created. Now, what's really important is that There we go. My trash can wasn't working. When you go to actually set up your Azure SQL database, what you'll see is connection. So this is where you choose your integration runtime. This cannot be parameterized. So that's important. The pieces that you would need to do are your server name, your database name, and your authentication. So it could be like SQL auth. It could be, and each linked service will have different options for the authentication types. Just because, for example, SQL Server doesn't support account keys like a storage account would. Same thing with like SAS tokens. So the authentication will just vary between every source. Now, what is nice is the fact that you can do from the Azure Key Vault. So if you have a Key Vault link service already hooked up, so I do, you can actually pass through dynamically secrets, which is kind of what I was talking about to say, hey, like store your credentials and user and your connection strings, store them in the Key Vault if you can. If not, don't worry. But the key part of this is that, okay, well, I have a server, I have a database name, and I have my actual authentication. So what happens if I need to connect? This works great, right? If I'm connecting to one server in my example, but what if I need to connect to, what if I want to reuse this connection to connect to any Azure SQL database? For example, if I have 10 on-prem SQL servers and I have 10 databases across, so I need to make 100 different link service connections, right? 10 servers times 10 databases on each server, 100 different connections. Do you need to create 100 link services? The answer is no, you do not. You can use one. So you can parameterize the server name, the database name, and even the authentication. In this example, my authentication is a system assigned managed identity. So I'm just using this data factory's authentication to actually make the connections and be the actual ID. So there's no need for it to be parameterized because it's just going to use the same. But if you did have SQL authentication, for example, yes, you can do the dynamic username and password and even get it from the Key Vault too. Now, the way that you do that is down at the bottom, it's going to be collapsed, but under parameters, you can just add anything you want. I just added these myself, parameter. You can add, that doesn't spell parameter. You can add default values if you wanted to. So if none are defined, it would always run. An example would be like always pointing to a dev server or always pointing to a dev location or a test location, unless it's told otherwise. That's an example. Now, how you would actually do this, so you click in, so if I want to parameterize this link service, right? I want to say, I wanted to pass through any sort of SQL database, any server name that there is, and any database name. What would I be able to do? So if you click into the actual box and hit add dynamic content, what's really nice is that it auto populates for you the parameters. So I just hit server name, and now I'm done. Database name, I select database name. Sure, you can type this out if you wanted to, but ADF is nice, and then we'll actually put it into the correct format and syntax for you. And now my database is connected. I can go through test connection, and you can see then the values are prompted for you to test the connection. Now, the question that I get asked all the time is, does this mean that my data factory can connect to my SQL server? Well, the answer is no, not typically, especially in regulated industries. The reason for that is we have a couple things at play here. So one is the network security of your source. Is it going to actually allow the integration runtime to make the connection? In the same way a gateway or another virtual machine reaches out to communicate over the ports, is it going to allow that connection? Yes or no? Let's say it does. Okay, you've set that up, you've whitelisted your IPs, you've done a really good job with that. So you have visibility. It could be through you add the self-hosted integration runtime onto a VNet and you peer it with your SQL server, and that's on a VNet too with your peering. However you want to do it, right? I'm not a network guy, but that is network security plays a part here. So just because you type in a server name, database name does not mean that you connect to it. The other bit is the authentication. So my user right now that's doing this connection is my data factory. And you can see the name ADF, AIA, MBDev. So as long as that user has to have the appropriate permissions at the actual database. So even though I just have a network visibility, I still have to have the authentication and authorization there as well. So that's something I always talk about with customers is say, hey, just because you have something set up and just because you can pass through any name doesn't mean that you are actually going to be able to connect. Now, another thing is, when should I create a different link service? So this sounds really great, but you may not want to parameterize all the SQL DBs, right? And this is just a question. There's no right or wrong here. It's a pure question. You can, if everything is sharing the same authentication type, the same integration runtime, you technically can share that link service. So in the example of you had 10 different servers with 10 different databases, they all can share the same link service. The scenario where you might not want to is, let's say 9 out of the 10 servers are dev and test servers, only one server is production. Well, maybe you have self-hosted integration runtimes and you have a dev, test, and prod, or just a dev and test and then a prod. So you have 2 self-hosted integration runtimes to segment the compute resources. Well, in that scenario, you would create a separate link service because they don't share the same integration runtime. So that's something important there. Now, also security-wise, you want to make sure whether or not they actually should share and have the ability. Like, I know, again, I'm not a networking person, but I do work with security teams quite often, and a lot of times there's internal requirements. And I say internal, I mean the customer requirements, internal, not Microsoft internal. Customer internal requirements to make sure that no dev like integration runtime or gateway has network visibility to another production machine. So I'll show you the technical possibilities, but it's just also important to know is that you may not have all of them running on the same link service, and that's okay. Now, what we also have is ADLS Gen 2. So what you'll notice is that this is a little bit different because it's a storage account. So I have this actually as entered manually. If I zoom in on, I do. So this is just, now I had to type this in. So it's just concat HTTPS. I pass through my link service storage account name, which I referenced down here, and just the DFS endpoint of the storage account. So that makes this dynamic because all these storage accounts, they're all DFS endpoints. You just pass through the storage account name and the RBAC for the actual identity. So again, this is just my ADF. Now, you can certainly build in a full-on path to this. So in our example, we're going to have files. We have, let's say, 10 different tables. There's 10 different files. Each of them have a unique file name. Yes, you technically can create this link service to point directly to the file itself, or folders or subfolders. If we're talking about the best practice for dynamic loading, taking out the security aspect of like the RBAC and things, you do want to put this at the highest root level because we're going to pass through, just like in our metadata table, we pass through the container, we pass through the actual directory, so all the subfolders to navigate and point to the file. So we're just supplying the base connection in the link service, and then we're actually going to pass through all the other information after. So that's why this is at the root level. Now, something that's very similar to this is API calls. You provide the base API root. So I think about like Workday, or I think about Kronos, or I think about PeopleSoft, or name your other SaaS or APIs. SharePoint, for example, if you're using SharePoint APIs, same concept. You pass through just the root API, and then you pass through at runtime the full-on location. And we're going to see all this. So if you're a little confused, about like, why is Mark showing me all this and we don't even know what the pipeline looks like? This is all in reference because then we're going to stay in the pipeline. Are there any questions so far about any of this?
Pretty clear. Anybody else? Feel free to come off mute.
Silence means compliance in this scenario. Okay.
You've really mastered this presentation, I can tell.
Oh, thanks. Yeah, I'm giving this talk in Jacksonville SQL Saturday for the Fabric one. So y'all are
Exciting.
That's already on the YouTube. So what's important? So now we have our link services. Trying to guess which one this would be. We'll just go to the pipelines and I'll pop through there. Okay, so those are the link services. So we have the connections built. So we have for SQL and we have it for ADLS and we have a dynamic. So we can pass through any storage count information. We're just assuming that Mark did his due diligence and went ahead and made the network visibility available and also applied the appropriate RBAC permissions to my source, my destination, etc. So now in my pipelines, I have some other pipelines, but I have some folders. So I have orchestration and ETL. So I have an AdventureWorks main, and then in my ETL, I have this, ignore this pipeline 59. I clearly was doing something. That's not a part of the ETL. I have AdventureWorks full reload and then incremental load. Oh, actually, I moved the main. So this is going to execute my entire enterprise ETL to load any source SQL server into a destination SQL environment. And we'll do full loading and incremental staging and incremental processing. I have 2 tasks. Well, technically 3. I do some encapsulation, but this is it. It's simple. I'm a big fan of simplicity. I also am like, sure, you can over-engineer things for certain scenarios, but simplicity works best. Also, good naming. So just to point out, and we're going to step through each of these steps. So in order to set everything up, if I click into the white space, I have parameters. So I have pipeline parameters here, and these are going to look familiar, right? They should resemble what I have in the metadata table. So at the high level parent pipeline, I have some parameters. So I've hard coded it of source server name, the database names, target server name, target database. I have a load indicator being daily, so that's just part of that. Just kind of showcase the flexibility if you want to mix and match some things. And then I also have a waterfall look back days of being minus 120. The reason for this is that I have had experience where to say customers will go, well, we have a reliable waterfall column or reliable date field, but we don't really trust it for them, and where things, it might not get updated, but we know everything from the last 4 months or the last 3 months to today. That's good. Like we need to just make sure, or everything beyond that, sorry, is good. So we need to make sure that we're loading the most recent 3 months or 4 months every day, because we don't know, because that's kind of the lag SLA. And the biggest thing is, right, you might not be able to change that as a DBA or a developer. You might not have any influence over that. That's just the way that source system is. So this just adds some flexibility around it to where you can actually define that at the pipeline. Now you can certainly pass it through to the metadata table, because let's say different tables have different, kind of SLAs like this. Like one might be 3 days, one might be, 4 months, one might be a year. You don't need to pass this through as a pipeline parameter. You don't need to pass any of these through as a pipeline parameter if you didn't want to, right? It's just kind of showing you the power and a lot of options that you have. So when this would execute, these are the parameters that would be used for the base. Now, why does this matter? We're going to start off with the full reload section first. So the very first thing that I have is a lookup task. I have this name, just full reload lookup metadata. what you'll notice is that there's a source data set. So I'm going to skip all this and we're going to come into the source data set. So source data sets, or just data sets in general in Data Factory, they represent actual data that's living inside of a link service. So think of the link service as you're pointing to the, you're pointing to a server in a database. The data set's actually what's in the database that we're grabbing. So in that example of, we have one link service for all our SQL servers and SQL databases. Well, what do we do for all of our tables, right? So we can't have a data set for each individual table. We would have thousands of data sets. That would just be crazy. So what do? Well, we make a dynamic data set as well to be able to identify any table inside of our link service. So what you can see here is that in my link service, it's the Azure SQL DB. And if you forget, I hit the edit and we can see that it's parameterized with the server name, database name, just like what we created before. Now, what's important is that I'm going to pop over. This is what it looks like normally. I add on the right-hand side under parameters, I added these parameters in. Like I said, you can add, anything you want. New param. So I added these server name, database, schema, table. What I have chosen to identify as a unique table, right? So it could be different servers, could be different databases, schema name, table name. So what's important is that these link service properties get actually passed through from the link service. So if you remember, these are the two parameters, server name, database name, that are passed in from the link service. So anytime that I'm referencing this link service, because it's parameterized, it will force the data sets to appear with their own link service properties. So you can see here, you hover over the tooltip, and it says these parameters properties are defined on link service. So this is how the link service information is getting passed through to the pipeline, is through the data sets. So the link service is here. It's given us our parameters. We went ahead and created parameters. I'm just going to get rid of this new param just to avoid confusion. So I've defined these. So even though they're you want them to be the same name just for simplicity. So I created additional ones, server name, database name. These were not pre-populated from the link service. But what I can do is, so now I want to pass through the parameters. So what can I do? Well, in the server name, I hit add dynamic content. And we do server name, database name. What you'll notice is that these actually say data set because these are the parameters defined at the data set. We're not doing the link service ones. So if you hit edit, see how these say link service, because those are parameters defined at the link service. These are parameters that are defined at the data set that are going to get passed through to the link service. Now for a table, you can get, I don't have anything here because it's parameterized. But what I want to parameterize is I hit enter manually. And it's already pre-populated for me, but this is where I'm going to pass in the schema name from the data set and table name. Now you could add in, there's lots of other functions that are inside of ADF to do really, concats or replaces, things like that. So you can work with the expression language for sure. But for us, we're already going to define these things. So we're not going to need to do too much. So now we have the parameterized data set, right? So we have the link service and the data set. Now, how is this actually used, right? So I kind of skipped this step. I went into the pipeline to show you. So now, when I'm calling, so this is just a lookup. So when I do a lookup, you have to choose a data set that you're going to run it on. Because remember, data sets are the representation of a link service. So if you're going to run, let's say, a lookup, it's like, well, what are we looking up, right? So this is what we're telling it to look up. Saying, look to this data set, Azure SQL DB. What you'll notice, the new param came through. That's hilarious. I'll have to refresh, but for now, what you'll see is that actually these flow through. So from our pipeline, we're able to pass through a parameter that would get passed through to the data set, which then would get passed through to a link service. So this is where we have the pipeline parameters. So if you remember from the parent pipeline, we had the full like source, target, and source server name, source database names, target server, target database, the load indicator, and the waterfall lookback days. We had all of those. So we're able to pass through these and identify them. So you can see that now this says target server name, and this says target database name. If I had no idea what I was doing, I pop through and I just come down here and I click it. In the parameter section, there's also system variables, so you can pass through things like, for example, if you want to pass through data factory name. Same concept, it pre-populates it for you. Now, this is where we're doing a lookup on the metadata table. So we're gonna get all those values. So this is wherever your metadata table or file would be. So in my instance, I have it on my prod server. So my prod server is also my target or my prod database. So that's where I choose target server name, target database name. Now, I'm going to run a query. So I don't want to define a schema or table name, but it will yell at you if it's just blank. So if I just had this, it's going to yell at me saying that the parameter is not supplied, which is okay because we can just put any value in there. It's not being used for this. Remember, this is the scaffolding and the template. So we're going to reuse this data set later on where it actually will be populated and actually used, but it's not used. So we just need something there as a placeholder to let the syntax errors go away. And obviously this new param will not be there. So in the lookup activity, you can choose things like table, query, or even a stored procedure. In our instance, we're going to use a query. So this is where we can actually pass through parameters inside of a SQL query. So this is just a SQL query to that exact metadata that was showcased in the PowerPoint. So meta ADLS underscore metadata. We have filters for the load indicator. So this is where coming from the pipeline parameters, it equals daily, spoiler, and the load type equals full. So we only want to grab the full tables. Now, if you had a file, if this is a file, right, you can't run a query on top of a file. Obviously, unless it's like in a lake house and it's a Delta Parquet, without getting into that, right? If it's a file, let's say it's an XML or if it's a JSON, right? Yes, you can create an external table, sure, referencing that. But if you just want to pull in the file, right, you would have to pull in the full file and then filter the values after. So this just offers you the ability to filter it this way, so we only return the rows that we need. It's metadata, so it's not a crazy amount that you're doing. Like we're not talking about gigabytes of things, so it just might be just cumbersome. But this is where we just are pulling just the load type and target table. That's all we're doing in this step. That's all that this is doing. So now what the output looks like of that. So full read load, look up metadata. My input, you'll see select load type target table, new line from metadata table. Load indicator equals daily. And load type equals full. What that returns, so this is the output. What we'll see is that now it tells us that there's eight objects returned, and it's putting these in the value array. So that's important for the next step. It's just that this is an array. It's going to have values for load type full, and you can see that these are the different tables: customer, product model, product description, product, etc. This is my favorite one: product model, product description. That's just, Kimball would be proud with that. So what we've done so far is we've looked up the 8 objects for the full reload. So we have them. Now what? Well, conceptually, we want to loop through them, right? We want to pass all of them in to be executed. So what we would do in Data Factory is a for each loop. So this for each loop, under settings here, there's a few options. So sequential, this is saying that you need things to run in specific order. So this will not run in parallel. This will run one at a time in the order that it's passed in as. So our top one was customer. That's the first one. As we know in SQL, there's no guaranteed order unless you define an order by. So if you needed something to execute in order one by one, in your lookup, you would perform that ordering and then pass that list through. In our case, the array, so it would be an ordered array. Pass that through to the for each loop, which then would execute them sequentially in that order. There's various use cases for this, but I really don't see a lot of use cases because we do want to execute things in parallel. We want to execute them in batches. So that's what this next one is, the batch count. This would define how many parallel streams that you would like to send inside of your for each loop. So I believe, I forget the max number. I typically see about either, depending on the data factory and the runtime, I've seen it go from like either 5 to like 12 to 15. So anywhere in that range, I would say is typically normal. But this is also what I describe as, so depending on what your stuff is doing. So in our scenario, we're passing through these and we're hitting a source SQL server. Well, that gets translated to SQL queries. So we're hitting the SQL database, our actual SQL environment. Now, do the same thing across any technology. If you're calling an API, you're hitting the API server. If it's Oracle or MySQL or Postgres, you're sending a query, right? You have to extract the data, and the only way to extract it is through a pull, and that pull happens through a query. So just because you can send 10 parallel queries from Data Factory has no idea what's going on in your source system. It doesn't care, right? It's just, hey, you told me to execute what I can do from a batch perspective, and I say 10. Doesn't mean that your source system can handle 10. That is one of the biggest, not mistakes, but biggest performance patterns that I see that are issues amongst customers. Like, hey, like this is running really slow. It's taking, an hour to send up a table that's, 20,000 rows. First thing you should do is check your source system. If it feels abnormal, it probably is, and you might have some locking, right? I've seen some pretty crazy stuff. I've seen folks call views, and it kicks off 5 parallel view calls, and all those 5 views are referencing all the same exact tables. So they ended up just like locking each other out for hours, and they couldn't figure out why. So that's one thing to check. Now, let's say in a scenario, your source system can't handle 10 parallel calls. This is where you would actually define saying, let's only pass through 3, right? Let's only make sure that 3 go through. So that's where you would define that. Now, the most important part of the for each loop is this items bit. So this is actually saying, what are we actually, doing for each? Which items are we doing for each? Well, this is where I take all this out. We want to do the output from our lookup. So if we come down here, we see activity outputs. And because I did good naming, this is also a reason why you want to do good naming too. So full reload, lookup, metadata, activity output. These are all available to this for each loop. So I want to do the full reload, lookup activity output, and it places this. Now, that's great. But there's one more step. Because the values that we know, or all the objects are inside of that value array, we do want to place through value. So we do dot value. One of the few things that we do have to add on, because technically that is the full output, but we just want to filter it just to the value array. So now we would have all of those objects available. So the for each loop now we've looked up the metadata for the full loads. We've passed through the table names because in my scenario, that's how I identify the unique record. There's only one table name per. So you just want to make sure that you can identify a unique record. You can pass through as many columns as you want. And we're going to see that later on too. But for now, all I need is the load type and just the table name. Now, inside of the for each loop, so I click onto it, I can tell I'm in the for each loop. It's because of this. Now, I've chosen to execute another pipeline. You don't need to do this. So I've encapsulated the logic. So the logic to execute the full load, I put into a separate pipeline. You don't need to do that. You can include all the tasks here. I just prefer it this way. This is a Marc thing because I have OCD with monitoring. I prefer to see when we go through the for each loop call. So this here, so this full reload load tables, I prefer to see just 8 different pipeline executions versus 8 different combinations of copy activities and script tasks and whatever else is going on inside those pipelines. I would prefer to keep it clean on the parent pipeline. That is just a me preference. That is not a technical need in this solution. I just find it a lot easier to troubleshoot and keep it clean. So just to kind of get back into here. So this is executing a pipeline. Now I'm going to pop over to this pipeline really fast because I'm going to show you, don't look at that yet. On this pipeline, I have parameters. So they're going to look very, very similar, almost identical, except for the waterfall columns. Target table, source server name, you get the picture, right? This is defined on the child pipeline. Now, I don't have any default parameters in here, but you certainly could. Why is that important? Well, this execute pipeline task in the settings, when I hit the drop down and choose a specific pipeline, it will pass through just like everything else. It will actually pass through all the other parameters that need to be filled in. So it's really nice. Now, you'll see that all these are the exact same. So we have source server, source database, target server, target database, load indicator. These are all coming from the pipeline parameters from the parent that we've defined. So these are already ones that were put into the pipeline. But the target table is coming from the item. So that list, because we're doing for each. So each item inside the for each list will be executed, will get its own pipeline execution. And we're passing through which item it's currently on with this identifier. So each pipeline can get their own unique execution. Now, how I do that, again, I'm in this add dynamic content. My for each iterator here, I go down, full reload, it says current item. So now it gives me all of the options. So I only had 2 columns. So what's available to me is load type and target table, because that's all I had there. Now, what's nice is that IntelliSense works. So I type the T and it tells me all of my options. So target table, table name, target server name, load type. I know from my work that I just know that it's target table because I know that's in the for each loop. If I didn't know, I can always come back to the main pipeline and I can look to see it's not going to come in on the for each loop. It's just going to tell me that I have 8, the amount of items that I have. But I can go back to the lookup activity and I can look to the output and I can see, oh, that's right, it's target table. That's what I'm passing through. So, and then you would just want to make sure that you go through and that you double check that the for each loop is actually calling the right output and the value. Any questions so far before we look at the full load pipeline? Okay. So at this point, we've identified no work has actually happened, right? All we've done is we've gotten the list of what we want to execute, and we've passed that through, and we've got it to loop, and we've called a pipeline to do the work. That's where we're at for one item. So now what this looks like, so we have our parameters, they're passed in. Our first step is that we have a lookup. Same thing. If this looks familiar, it's because it is. That's kind of the beauty of it. It's extremely repeatable. It's a pattern. This follows the same exact lookup. We're looking up to our metadata table. Now, the query has changed. So we do a select star. Again, please don't hate me for that. I just did it for the demo. It's really easy. It's really simple. That's not best practice. Please identify the columns that you need. So I pass this through. What you'll see is that we're filtering on the target table, which is from the pipeline parameters, which is from the for each loop, which is from the original lookup activity from the parent. Same thing with the load indicator. If you want to pass these in, so this is target table, you would just have to, it places it for you there. All you would need to do is add a single quote, add the at, and then end it with a single quote, and do our nice little squiggly brackets. That's just syntax wise that you just need to do. So in our input for our lookup, this is actually for customer address, this execution that ran. It just picked one at random that I had for this. And the load indicators daily. Whoa. And now the output of this is that you can see. So I had, because I'm only getting one in terms of one result, I have first row only checked off here. You can make this dynamic too. But I have this checked off because I know I'm getting one result. This just makes it a lot easier to extract all the values. And the reason for that is because the output will not be an array. It will just be JSON. So this is our full metadata result for the customer address table. So again, this is all prep and teaser. So we've now are locked in on a single execution. This single execution pipeline has now identified the unique record of what it wants to do and pass all that in. So now we're actually going to copy data. So we have the copy activity. So copy activities, they move data from point A to point B. They are a one-trick pony, but they are really, really good at that one trick. If you're trying to move data from point A to point B, this is what you should do. It's optimized for it. Sure, it can do some transformations. When I say transformations, I'm talking about convert a file format, unzip, zip files, rename some columns, rename files, copy file. It can do things like that when I say transformations. This is not what you would use to actually, join tables together, create derived columns. Like that's not what this is. That's not what this does. So that's what we're doing. We're moving data from point A to point B. Point A is a source SQL Server environment. Point B is ADLS Gen 2. So we're putting it to a storage account. That's what we're doing. Now, in Data Factory, it's going to be source and sink, like kitchen sink, but that's actually your target or your destination. So we'll see that. So in the source, right, where are we pointing to? Well, it's the same data set that we've been doing, right? Because everything's an Azure SQL database in our example. If this was an on-prem SQL server, that would be what you would point to. If this was Oracle, or if this was an API, it'd be whatever your source is. Ours just happens to be the same exact as our prod environment. So it's all the same. So we're using it. The server name and database name are coming from the pipeline parameters. These pipeline parameters, these were passed from the parent. So even though we're in the child pipeline now, and we're identifying the pipeline parameters, these were the values passed from the parent on the actual execution. The schema name and table name, they're coming from the lookup. So that lookup activity just immediately, right? Because we never included any of these other rows inside of our metadata table. So we have this lookup, we have the source schema, and same thing for the table name. We're not doing a query. We're just basically this is a select star, right? Because these are full reloads. Either there is no change logic, we have to do full load, or we have to, or they're just small enough dimensions that they're okay performance-wise to be fully loaded. So that's why we just pass through the actual table. This is essentially doing like a select star at the source. And that's where here we just see table. You can choose your partitioning. You can actually make that dynamic too. You can change isolation level. The DBAs out there, I don't see a use case for doing this at the pipeline. You should always honor the database level isolation because it's set for a reason. And if you don't know what that reason is, then some DBA, I hope, would know the answer to that. And if no one knows, then, and if you're seeing problems, then you should all probably have a conversation. So this is getting the source. Now the sink, which is our destination, which is ADLS, this is a different data set. So we pop open this bad boy, and what we see here is that this is the link service to ADLS Gen 2. So that's just that root, right? Where we said, hey, this is just the DFS endpoint. We're going to pass through the account and all the other goodies later on. So on the parameters of this data set, I add the parameters that I need, right? Similarly to the SQL one, this time I'm doing storage account name because that's actually the link service one. So again, just making that the name for simplicity. Storage container, container directory path, file name. If those sound like metadata tables, or metadata columns, is because they are. So again, we have our link service property, the storage account name, coming from our data set storage account name. This file path, this is where we're putting in the storage container, container directory path, and the file name. These are all coming from our data set parameters, right? Because we know that they're going to be actually fed through to the copy activity because the copy activity is referencing this data set. So this will all be passed through to identify where we're going to go. Now the compression type, you can choose none, gzip, snappy, ISO, or ISO. You can also make this dynamic too. I don't have it dynamic. The reason for that is because I've made a point. Is you have our data set. So data sets can also be dynamic if they're pointing to the same link service and if they have all the information the same. Obviously, the compression type can be dynamic too. I don't have it dynamic. So in this case, I have it hard-coded to be snappy compression. You don't need to, but this is just an example where you can see my naming of this is for, now you can't parameterize the file format. So this is a Parquet data set. And it's snappy compression. So that's why I name it Parquet Snappy. So anything that's hitting ADLS Gen 2 and that link service name, and if it's Parquet and if it's snappy, I'll be able to reuse this data set. So that's why we see these data set properties here. So everything is coming from the metadata. And everything's going to be hitting this metadata output. Copy behavior, we're not defining anything. You can choose flatten hierarchy, merge files, preserve hierarchy, etc. You can define your max concurrent connections, your block size. You can actually add metadata. And max rows per file. I don't have any mappings in here, but if you wanted to change your schemas or do dynamic schema, it's a little bit difficult to do in a dynamic setting just because the schemas will be different every time. Not to say it's impossible, but what you would need to do is basically maintain a crosswalk file that would actually go through. Now you can add dynamic content for sure. So if you always had you could pass through the source column name, and if you always do like a suffix onto it or something like that, you can do that. But if you need to completely rechange everything, it's going to be best to have a crosswalk. What's even better than that is just land the data into wherever it is raw as is, and then do your transformations in a different compute layer. Just because for simplicity, the copy activity is really good at moving data from point A to point B, but it's not great at transformations at complexity. So that's where if we're talking about higher level complexity, you're most likely going to do that elsewhere.
Quick question we have in the chat, Mark, and you may have already gone over this, but what was the reason you're using ADLS as an intermediary landing spot? Just to illustrate this, or to make it generic, or for speed, kind of like you were just talking about?
Yeah, so there's a few reasons for that. So one can be for performance, especially in a scenario going from on-prem into the cloud. SQL and other formats too are proprietary, so they have to get extracted out and landed somewhere. Even though, and again, I haven't tried it in a while. Even though you may technically be able to land it right into SQL, there's still lots of transformations that are happening outside of there because you're not able just to move a SQL file, leave it there. Like that's what backpacks are for, right? Import, export, taking those native files. So we're having to convert it anyway. So performance can be a factor because typically your on-prem server is going to be a little bit more constrained for resources than where your target is. And that's just simply because of just the scale of clouds, but more importantly, the activity may be a lot less on wherever you're going. Now, the other bit of that is that, again, we're talking about physics. So you're moving data from an on-prem data center, and again, this is this scenario on-prem. You're moving data from an on-prem data center through an integration runtime, which may or may not have a lot of bandwidth. Same thing with your express route or a site-to-site VPN that you're using to get it up there. Typically, are constrained with resources compared to running something natively or local in the cloud. So by putting it into AWS, we've gotten it into the cloud. Now we can start to leverage cloud compute and resources, which are going to be a lot more scalable and cheaper to run than something on-prem. So there can be a performance aspect. The other bit is, well, if we have to land it somewhere, a lot of times, if we land it into AWS Gen 2, so the intermediary storage, other folks may want to get to that data. And the classic example is data science. Data science, machine learning, and we're talking about all AI. Yes, AI can, they can run SQL queries, et cetera. But for your big machine learning models or just any sort of data science or really anyone else that just doesn't want to use SQL Server and they want to get to your data, well, they may need that, for example, with a Spark engine in a file format. Sure, they can use the JDBC connector from Spark to connect to SQL or any other database, but it's really not efficient at large scale. So if you're already having to move data, you can land a raw data inside of your data lake on your way to landing into SQL to kind of have a multi-purpose. It can be used for SQL because the loading into SQL from AWS Gen 2 or storage that's local to that cloud environment and in the same region is going to be way faster than loading it to on-prem, or straight from on-prem because of the previous reasons. So it's kind of like killing two birds with one stone. It's kind of the multi-purpose use case for it. And also to be generic too, like if none of that applies. Like in my scenario, I'm not moving from on-prem, but there are some scenarios where ADF would, you would need to stage data. A classic one is I have customers that use Snowflake as well. So another proprietary format, you can't load or extract from Snowflake into AWS or into Azure without staging it. So you would have to put it in AWS, and then it comes into like that multi-purpose kind of scenario of like, well, if you already have to land it to something, let's make it something that other people could use too. Any other questions on that? I see you answered in the chat that I answered it. Okay. So this is moving the source to the sink. We covered all these mappings. So what we can see here is, and I have this named source system to ADLS. So our input, you can see all these different settings that we've done. Our output, all this stuff. The reason I'm going through this quick is because you can hit these glasses, which are the details, which is a really nice screen for the copy activity. I can see, data size that's read, data size that's written, the number of files that are written, row counts, peak connections, how long it took, the throughput I got, the number of DIUs used, the number of parallel copies. Now, this is really nice. So there's a breakdown of the queue versus transfer. So the queue time, this is, and I'm putting up the tooltip so you can see that as well. This is basically waiting to execute. There can be various reasons why a copy activity is waiting for a resource. The most common, you can see that here, is like if you're using a self-hosted integration runtime, because that's a VM, it has a finite amount of resources. So your CPU or your queuing on that in terms of concurrency can max out. Just like any other machine or any other server out there, it can get bottlenecked. So it waits, right? Waits for resources. So if you're seeing high amounts of queuing here, you might be like, whoa, what the heck? Data Factory is terrible. It's taking forever. Well, that might not be the case. Your machine might be really slow. That's the IR. It might need to be addressed, to be scaled up or scaled out. Then comes the actual transfer. So this is the actual step that's getting your data and moving it and landing it. Now, what's included in here is the query to run it. So Data Factory, again, has no idea what's happening at your source. This could say, you could look at this and go, why is Data Factory running for 4 hours for this file that's only for this table that's only 417 rows? Data Factory sucks. Well, no, that's not the case, right? Because you have your queuing that may be a factor, but if you see this large transfer time, absolutely check your source, because Data Factory doesn't know if all it knows is that it sent a query. It has no idea if it's waiting because there's a lock or there's a block at the server level and it's waiting for that to run, or if it's actually running, right? Data Factory doesn't know. So it's just going to show up as long time. This also includes the writing to the sink too. So you get to see all that stuff in here. So that's really, really helpful to see. And it's a nice like little visual. So we can see that. Now, our next copy activity, so now we've landed in ADLS into a Parquet file. Now we want to load that into Azure SQL database. This is a full load. So now it's kind of the reverse, right? Our previous sink, which is the ADLS Gen 2, is now our source. It's literally the exact same thing because nothing's changed. We're just picking up the same spot. So our source is the exact same as what the sink was. And our sink is actually it's going to be the same data set. And it's going to be now, instead of the source, it's just all going to be target. So you can see target table, target schema, target server, all this good stuff. Now, because it's a sink instead of a copy activity, we can choose the right behavior. So you can choose an insert, an upsert, a stored procedure. You can do bulk insert table lock. Again, these can be all parameterized. You could use an existing table option. Auto create, again, can be parameterized. I'm choosing to auto create the table. There are benefits to both use existing, which is defining your schema, defining your data types, and really just kind of honing in on that, versus auto creating the table. So you can see here, like automatically creates table of non-existent in source schema, which is not supported when a sort procedure is used. So it will try to match the schemas. Now, what's important is that you have to make sure that in our scenario, our source is ADLS Gen 2. It's a Parquet file. So varchar doesn't exist, right? There are things that in terms of mappings don't align. So that's where you could choose existing can be a beneficial piece if you're going to do all of your formats changes. But again, may or may not be needed. I'm choosing auto create, and I'm actually executing a pre-copy script. So here, this is an if exists. I'm just dropping the table. That's all I'm doing. Or I'm sorry, I'm truncating the table. So this is the first thing that I'm doing for full loads. And you can see this is just, I'm passing through a SQL query with our schema and our table name. So it's just looking to the actual information schema tables where it exists. And if it does, it's going to truncate the exact same schema dot target table. A nice begin end. And then because it's pre-copy, that will run first, truncates the table, and then it will auto, and then it will go. Now, the reason why I have auto create as well is because if I add new tables to the metadata table, well, now I don't have to go through and edit the pipeline. I don't have to create the table ahead of time because that would fail. This will be able to handle if new stuff gets added. It's just as long as it's there in the source and there's no other issues along the way, it will auto create a table for you and go on its way. So that's also another reason. That is a business decision to make sure. If you want it to fail, you certainly can. And here's our nice goggles. And you can see the reverse. This time it actually made 2 connections to that file location. So that's the full load. So at that moment, we fully reloaded the tables, right? Taken from the source, we just did a full table query, and then we've actually loaded it through. We truncated the table. Now, what you would do from there, right? This is just simplicity. Like this could be just loading a raw table, for example, and then you would continue on with your ETL or ELT, whether it's stored procedures or whether it's notebooks, whatever. Again, completely name your tool, right? This is just kind of signifying of like how you would do it from simplicity. So that's for the full loads. Any questions before we move on to incremental?
We want incremental and we want it now. Let's go.
Okay. Give people what they want. So the incremental, it looks the exact same as the full loads. Because from the full load side, the pattern is going to be the same as on the incremental, right? We're going to move some data from a source server. We're going to land it in ADLS, and then we're going to land it into our SQL database. And we need to query the metadata table. So conceptually, it's very similar. Now, there are going to be some slight differences. Now, in the lookup activity, we're still hitting the same it's the exact same lookup. The only difference is that we pass through incremental here. Again, you could parameterize this if you wanted to. I hard code it just for simplicity. And you can tell me that I'm wrong and this was a dumb idea. I take no offense. So these are incremental. So in our output from our lookup, we can see now we only have 2 tables. You can see load type, incremental, target table, sales order detail, and sales order header. Same exact thing. To the for each loop they go. And the only difference is that this is pointing to the incremental reload output for the metadata and the value. And this is also going to execute a pipeline that has parameters. So again, everything's the exact same coming from the pipeline parameters. The only actual additional one is this waterfall look back days. So this is 100 and it's minus 120. but everything again coming from pipeline parameters except for the target tables coming from the item. One thing I didn't talk about before is this setting, wait on completion. It's checked. Basically, this says, am I going to execute this pipeline? And am I going to wait for it to complete before exiting the for each loop and be done? If you leave this unchecked, all it does is to say, I've executed the parameter, I've executed this pipeline, and I'm done. I don't care if it finishes. I don't care. Doesn't matter to me. And I always view it as like if you're on like a loading dock and you're just throwing things into the truck and then all of a sudden you're like, everything's in the truck. I don't really care. I'm done. And no one's driving the truck to make sure that it gets to wherever it needs to go. It's kind of the same concept. Do you need to wait for the truck to get there with the goods to mark it as complete, the delivery complete? Or is your job or your responsibility only just to throw it in the truck and that's done for you? Same concept. Do you just need to execute it and not need to wait for it? Or do you need to wait for it? This will be important for dimensions and facts. Executing all of your dimensions, you definitely want to wait on completion before you would move on to something that has a dependency later, because it might not finish in time and they might overlap and there could be failures because it's referencing an object that doesn't exist. Okay. So these are the parameters on the incremental. So now we're inside of the incremental pipeline. Our lookup table is the exact same thing. This is actually the exact same as the full load. It's the exact same because at this point, it's only scoped to the item, right? So at this point, it doesn't care if it's incremental or full. It's just looking at the table item. We've already done that before. Now, this is where things start to get different. So we have our source. So it's our SQL server. And we've already pulled everything from our metadata table. So everything from here is going to be the exact same, right? We pass through the source server, source database. This time we place our X's actually. We keep them there because we're actually going to run a query. So again, please don't yell at me for the select star. This is where you would pass in the parameter from your metadata table for the columns. So please don't hurt me. It's just for simplicity. But this is where I'm concatenating. So a select star, or really your column names, and I'm passing through, I'm doing square brackets to make sure it doesn't break. The incremental load, the output, the source schema, dot, source table. And then this is where I'm actually passing through a where clause, doing a convert date, passing through that waterfall column. So in our case, it's modified date, greater than equal to date add, day, pipeline, waterfall look back day. So minus 120, get date. This is passing through the query to identify just the change records. So when I mean by saying this works for really any source, it's because if you're hitting Oracle or MySQL or Postgres or Cosmos or ADX or really anything, just change your syntax. Yes, they all can run some flavor of SQL, or they all can be queried in some way. Data Factory doesn't care. You just pass through what's needed from the syntax. So this is where you can absolutely plug and play as you see fit. You can have the metadata table shown of like, well, some of these sources are Oracle, some of these sources are SQL, some of these sources are APIs. You can have them all in the same metadata table if you wanted to. And in your different sources, obviously it would be a different like link service, it'd be a different, et cetera. But you'd be able to reference the same lookup and pass through to any source because again, you're controlling what's being sent, and that's how it's through these expression builders. At least for the SQL on the query, that's how we're actually passing it through. API calls, obviously, you could just edit the API call directly, but for the queries, this could be anything. The sync, everything's the exact same. It's the exact same as the full load because at this point, the concept is the same because we're going to load we're taking a small bit of the table, but we're going to load it to a staging table. So the loading to a staging table is actually the same exact concept as the full load, right? We truncate the staging table and we replace it with the new data. So we've already identified just a change record. So we're just moving it to a file. And then from there, we're going to have to load it into a staging table. Well, then just to kind of show you the output. So source system here, our query looks like this. Select star from sales LT sales order header where convert date, modify date, date add minus 120. That's what it gets translated to, and that's what gets sent. And you can see here's our good stuff. It said 0 rows because I did not make any changes to this table. So of course it didn't identify anything, but if it did, it would show under the rows. So that's not just an issue there. I guess I did not run the script, but the concept's still the same. So once we've now landed it into ADLS, right, it's now just the incremental changes. What we do is treat it just like a full reload. So this is where the source is the exact same as the previous sync, just like the full reloads. The syncs, everything's going to be the exact same, even the truncate table. The only difference is that the schema name is a staging schema. The table name is a staging table, and making sure in our pre-copy script, we're also hitting the staging tables and staging schema. Because again, we're going to do our lookups and our incremental load off of doing a table comparison between the full copy and then just the what's changed copy. Everything's the exact same. Auto create, all this behavior. And then now finally, the data has landed inside of SQLDB in a staging table. Presumably, I already have a full copy of my data. And so we still are using the same link service here because we're executing a script task. We have the server name, database name. We're going to execute a non-query. So this is like update, insert, deletes. Queries are actually for like select statements to be returned. So what we have is this big thing. Don't worry, I'm not going to make you look at it in here, because we're going to go to SSMS. Before we do that, I have a script parameter. So I have file name, and I'm passing through the value from our lookup table, our incremental table for our file name. Because again, we're just identifying a unique record, and that's exactly what my new unique record is. And I'm specifying that the direction is actually input. Now, you're probably asking, Mark, why did you make this a script task? Why can't you make this a stored procedure task? The answer is you absolutely can. The reason why I made this a script task, which may make some DBAs or developers cringe, is that by making it a script task and putting the logic in here, it would allow users that wouldn't have database level permissions to edit stored procedures to be able to orchestrate and edit and mess with the ETL. I spoke with some folks around for this, and having the script task made it more robust for lots of different personas of users. May not fit for your organization, right? You may have developers that are in ADF and they can't mess with stored procedures or things like that on the source. So you would just have them point to a stored procedure. You absolutely can call it a stored procedure, and same concept, you pass a parameter into it. There's an execute stored procedure task even. If I was in my stored procedure task, So we would call the same link service, and you'd be able to parameterize it, and you can add your own store procedure or your own parameters. So the reason why the script task is here, again, you don't have to do it. It's just that it just adds a lot more flexibility to users that may not have access or permissions to perform that level of operation. If you're putting the lens on a DBA hat, everything should be through a stored procedure, so you have full visibility, so you can control performance, and it's a lot better for monitoring. And if you're from the ETL developer who doesn't have access to do any of that stuff, you probably want this, right? So it just depends on the hat that you wear and your organization for which one would make sense. I'm going to uncomment these. So at the top, all this is doing is just, and this is going to look very familiar, file names, target table, staging table. These are all metadata pieces, right? Now, there's some new ones. There's some new folks to the party, such as like delete statement, insert statement, statistics statement. But what's important is that we have a file name, sales order parquet, sales order header parquet, and that is what's used to actually filter the metadata table here. So we pass through that parameter. And again, this is manually in the file. It's normally commented out. This is what's passed through to the actual script task from the pipeline. So this wouldn't be defined in the sort procedure. It's just commented out for manual runs, like what I'm about to do. So all of this is just getting that, hey, target table, target schema, staging table. Now, I am lazy and I don't like doing the staging schema dot, so I just did it once for the full name. Now, something else that I've done here is getting the target table column list. So I get this from the destination. Now, the reason why I do this is to really ensure that things, because, for example, we're going to do the, like if you did, so our staging table, we do a truncate. So the schema is staying the same. And if you're specifying that the columns are the same, then yes, right? But let's say you're opening it up wide up, right? There's no judgment here. If you open it up wide open, and you have, schema drift, let's say, and you don't want that to fail, right? You want to bring in those new columns, and you want to do a drop table and recreate table with the auto create, right? Well, what would happen? Well, if you want to ensure at least some integrity, you can just go through and use what's on the database, because that's maybe something that you're controlling. If you're using an existing table, whichever, right? It completely depends. There can be, especially like I said, if you're doing the drop and recreate for the staging tables, the schemas could potentially differ between the full target table and your staging table. It may not, right? It may stay the same. You may not even enforce that, but this just always ensures that you're pulling your own target table column list from your destination. What's also important is that if you have identities, so we know that you can't insert in SQL into an identity field, you would have to turn the identity insert off and then turn it on again. So this just bypasses that. It says, hey, we're going to make sure we pull all the columns except for the identity, so we don't run into that error, and just concatenate them together. So that's all this is doing. So we've identified at this point all of the metadata for what's going on. Now, what I'm going to do is what we've forgotten about is how many primary keys there are, and how can we dynamically pass through. How can we have something that runs for one primary key, or if it runs for 3 or 4 or 10, right? I hope there's not 10, but I've seen crazier things. So what this section does is the column keys are split into just a concatenated list. Now I have them comma separated. I highly suggest just make sure that the requirement is that it has to just be in a format, a consistent format. Could be vertical bar, could be double space, however you want to do it. It just has to be consistent, because what we do is we actually split the string and create new columns is in their own rows. So for folks that are familiar with SQL, you might see where I'm starting to go with this. Because we need to generate a where clause. We have to identify the unique records dynamically across these different tables that have different amounts of keys. So this is the first step. So this is just a CTE. And then we're going to actually start to generate the where clause, which is the most important part of what we're doing. So really what this is doing is that it's taking that CTE and it's joining it on itself. The reason why the row numbers are there is just because it's going to join offset of one another. So basically what it's doing is identifying when there isn't another level. So in this scenario, there's 3. So the whole goal is to say, when is there going to be a third? Like when is there going to be, and we'll look at this, say big. I did say this is a live demo. Okay. So this is where these column keys are joined on one another. And so what's important is that this is the end one. So, and this is the beginning. So we want to identify when it's null because we're purposely mismatching it. So the null would mean that there's no other, there's no next column, right? It's going through a list to say, okay, 1 equals 2, 2 equals 3, 3 equals 4, right? That's what we forced. So by doing it this way, we can find out when there's no more mismatch in a line. Now, it may not always work for all scenarios, but for our scenario, we need to determine our syntax for if there's going to be 1 key, so 1 value, or if there's going to be 10. How can we automatically write that to make sure that we handle all the different levels and can also, more importantly, terminate that? So the way that we do that is by using a case statement. So this says case when that end column key is not null, which signifies that there is another key value. If it was just 1 key, this would immediately be null. So case when, and it's going to say in select, then we're going to do the column key from the staging table. And then it adds an and to signify that there's going to be another call in our where clause. Once there is a null, right? So column key is null. Then it's going to just do the same thing, but it's not going to add an and. Now, I'm not saying this is the most efficient way to identify change. I'm not saying that a subquery is exactly what you need to do, but this is a way to do it. And it's a very simple way to do it. There are lots of other ways. So you could do this in the join itself. You could just do this in a where clause comparison between the fields. You could do, if you wanted to, because we could pass this through with a merge statement too. This is just a way. So if you're saying, geez, I would never write my insert updates or my merges with this kind of where clause, I take no offense. This is just to explain the concept. I do not intend this to be like, this is the end all be all most performant scenario, but this is a way. So what's important is that it generates this where clause. So row GUID in select, row GUID from, and sales order, and then goes through sales order ID, and then it terminates. There's some comment on our code if you need to kind of do like a composite key kind of scenario. I had one customer way back when that like they needed to do a full-on concatenation of the keys and values to together versus doing like a join and join and join and. So that's there. Now we're going to build a select statement or a delete statement. So we're doing an insert and update. Well, the way that I've chosen to do the insert and update is, well, we have all the things that have changed. Why am I going to go through row for row and update a value and check if it exists, update it? If it doesn't, insert it. I'm just going to delete it because I don't care if there's 10 values that have changed or just one value that's changed in that row. I'm just going to delete it, insert the newest value. Again, if you're doing like slowly change dimensions or things like that, you would have to do some other things that you could certainly parameterize too. But in this scenario, it's just it's easiest to just do a delete and then an insert, which handles our insert and updates because it's capturing everything that's new. So we're generating the delete from, and that's where we're passing through our where clause. And then we're doing our insert statement. So our insert into the full target table name, target table column list, select from the staging table. There's a statistics update. So if you're running this, let's say in Synapse, or if you're running this in Fabric Data Warehouse, for example, you would most likely want to and even SQL Server, you can do this. If statistics are a problem inside of your database, then you absolutely want to make sure that you update statistics as well when significant changes occur. I can go on and on about statistics for sure. I have a big soapbox rant about statistics and things, but a little out of scope for this. But just know that you can make updating statistics as a part of your process. Then at the very end, all we do is actually pass that through to SP execute SQL and execute. Again, there are more ways to do SP execute SQL. I'm sure that the DBAs and other folks will be like SQL injection. I hear you, but for simplicity of the demo and concept, I'm personally not worried about SQL injection in my environment. I have it completely locked down, but you do what you would want to prepare and make sure that you do parameterize things in a safe, effective way. And the final product is this delete from, and here's our where clause. That was crazy that I moved that. Wow, I didn't know I could do that. Control Z. I was like, that's not spelled right. And so you can see at the top is our where clause. And then more importantly is our insert. And here's our full column list all the way down. And our next select statement all the way down, hitting the staging table. And at that moment, our ETL would be finished, at least for this part. Like I said, you can add in all these different pieces. You could execute stored procedures. You could make each of these pieces a stored procedure and pass through a stored procedure name to say, hey, yeah, we're actually going to, instead of doing this dynamic incremental processing or individual like dimension calls, what we can do is actually just pass through a stored procedure that has all the crazy unique business logic that your heart would ever desire for, and you can just execute those. Now, the last thing I'll show you before we're done is, so like I mentioned this previously, is I have OCD and I prefer to encapsulate this logic. You don't need to. You could have all four of these actually inside of your for each loop, and you would get all these tasks executed times however many. So in this case, we had 2 incrementals. So we would see 8 of these total. And now for the fulls, there were, I believe, 3 tasks. So 3 activities in here. We would see 24 because there's 8 objects, right? So to me, it's a lot easier to look at this, where I can pop in and see the input and see the target table and go, oh, let me go to this pipeline execution. I hit the output, I hit the value, and it brings me to that where I can see the encapsulated logic here versus seeing all of those items all within the parent pipeline. That to me is just overwhelming. I would prefer if there's because if 2 of these failed, let's say, I can just go to one of them and fail, but it's going to appear if I didn't have the encapsulation that one of these would fail and I would see it like 3 or 4 times. I would prefer just to see a single pipeline. But again, that is entirely personal preference. But that's it.
Would love if people had a chance to turn on their video, come off mute, and let's just give Marc a round of applause for the depth and breadth of what he went through on Azure Data Factory and how we can use metadata for our pipelines.
Yeah, thanks, Marc. That was really nice.